Welcome back, Year 5. In today's math lesson, we'll be moving on to decimal sequences. Now, all this is looking at patterns that decimals might follow. So they could be a pattern that counts up or a pattern that counts down. We have two learning intentions. The first is to use our understanding of decimal numbers to count and complete decimal sequences. So that just means we're going to get a pattern and we have to continue that pattern. Our second intention is to describe the rule that a sequence follows and use it to calculate missing terms. So that just means we'll be shown a pattern and we have to figure out what is it counting up by or what is it counting down by. And then once we know that, we can fill in the missing numbers in that pattern. 5. To start our lesson today on decimal sequences, I want us to try counting on from the number 4.7 in steps of 0.1, 0.01, and 0.001. Now this might look like a challenge at first because you might think, well, the number 4.7, it has a ones place, let me mark that, ones place, and it has a tenths place. But it doesn't have a hundredths place, and that's 100th, and it doesn't have a thousandths place. So let's look at it this way first. Let's look at a different number, and then we might realize that it's not as tricky as it seems. What if I told you instead to count on from the number 25 in steps of 100? That doesn't seem so hard, does it? The number 25 has a tens place and a ones place. But I'm asking you to add hundreds. Even though there is no hundreds place, you just automatically think to yourself, well, it's like there's a zero there right now. So for me to count on in steps of 100 from 25, I'd go 125, so that 0 turns into a 1, then 225, then 325, and so on. So you realize you would need to change the hundreds place, even though there was nothing there to begin with. Then if I asked you to count on in steps of 1,000, well, again, that number only has tens and ones, so the thousands place right now is empty. So if you wanted to add up in thousands, you would just have to add to that place. So it would go from 25 to 1,025 because that grew by 1 and everything else stayed the same. Then it would become 2,025. Then 3,025, and so on. Even though there was nothing in that place to begin with, you just think of it as having a 0 and then you add on to it. Well, it's the same thing up here when we're dealing with decimals. When I ask you to count on from a decimal number, even if you're counting on in a value that doesn't currently have a place filled, you can do it. Just imagine that there was a 0 there. Let me show you what I mean. So first we're going to count from 4.7 in steps of 0.1. Well, here's the tenths place, and this is a tenth. So it's going to go from 4.7 to 4.8, 4.9, then what? Remember, think of it like a 48, 49, 50. It's a pattern, always a pattern. Then 5.1, 5.2, and so on. We could keep going. So we just kept adding 1/10. But now we're going to do the same thing, but this time we're going to add 100th, and we're starting at 4.7. The hundredths place is over here, and right now it is empty. So I can imagine that there is a 0 in it. Now that I've imagined that there's a 0 right there, it's kind of easier for me to imagine counting on, because that 0 then turns into a 1. Then it becomes a 2. Then it becomes a 3, and so on. We could keep going. Notice the pattern. It looks like 471, 472, 473. Just keeps going. Now next, we're adding thousandths. So tenths, hundredths, thousandths. There is still nothing in that thousands place, so I'm just going to imagine right now that there was a 0 there, just a placeholder. So with that in mind, if I'm going to add up 1,000th, everything else stays the same. 4.7, nothing in the hundredths place, and now it's going to have a 1 in the thousandths place. Now let me add to that again. 4.702. Everything else stayed the same except for the place that we're adding to in our sequence. So it's going up by 1,000th. 4.703, 4.704, and we could keep going like that. So when we talk about sequences or decimal sequences, we're adding up or down. It could be down as well. Adding down, that made no sense. Subtracting. It's late, you guys. So we can either go up or we can go down by a certain value. Sometimes it will be small steps like this. Other times you might be asked to add or subtract a different value in steps, maybe 2.5 or 3.72, and you have to do that repeatedly. Just keep in mind the place value. Let's put this into practice now with the Discover. All right, so for the Discover page, I see Mo and Olivia, and they're in the garden. And Olivia said, these rose bushes grow 2.5 centimeters every month. I think that's going to end up being our sequence because it's saying every month, so it looks like it's going to be something that happens over and over again. All right, 1A. The rose bush Mo and Olivia are planting is 15.4 centimeters tall in April. How tall will it be each coming month for the next 6 months? Okay. I have an idea for that. I think what I'm going to do, since it's a pattern going up by 2.5, I'm going to make a table and map out the 6 months I'm going to need to look at, but I'm going to start at April, and then each time I'll just add up. Let me set up that table. All right, so I went ahead and set up my table. They want me to keep track of how the rose bush grows for 6 months. Sorry, let me just put something to weigh down the corner of my paper. There we go. All right, so in April, the rose bush is 15.4 centimeters tall, and each month is going to grow by 2.5. So I'm always adding 2.5, and I'm going to do that for 6 months, May, June, July, August, September, October. Now, the way I've decided to do this is that in each column, I'm going to take the height from the month before and then add 2.5 to it. So for May, it's going to be 15.4 plus 2.5. So that's 9, 7, 1. So in May, the rose bush should be 17.9 centimeters tall. Make my table a little longer. Normally I would tell you guys to use a ruler, but I have to do this with one hand so I can hold the camera. So please don't say, Miss Osborne, you did it without a ruler, so I don't have to. No, you have to. All right, the next one. Still, it's growing 2.5 centimeters. That's the sequence. So I'm going to add that height. 9 plus 5, 14. 1 plus 7 is 8. 8 plus 2 is 10. Carry my 1. 1 plus 1 is 2. So at the end of June, it will be 20.4 centimeters tall. Do you see what I'm doing? Every single month, I have to keep adding up. What I want you all to do is calculate the height for the rest of the months. In your notebook, I want you to create this table and follow what I'm doing. Take the height from the month before and then add 2.5 centimeters to it to find the height for each month. Now on to part B. It says the other rose bush is 87.2 centimeters tall. For how many months has the rose bush been over 60 centimeters tall? All right, so this rose bush must be growing at the same rate, 2.5 centimeters every month. And it's at 87.2 now. So I need to work my way backwards to see at what point it was 60 centimeters tall, so I can figure out how many months it's been more than 60 centimeters. I think the best bet for this is to create another table, but I'm going to work backwards. Let me show you. All right, so what I've done is I've created another table, and I'm going to be working my way backwards. So what you'll see is that at the start, I have now, and the height of that rose bush right now is 87.2 centimeters. And then I'm going to subtract to find how tall it was a month ago, then 2 months ago, and so on, and see how long it takes it to go to about 60 centimeters or just below 60 centimeters. That way I'll be able to see at what point, or how long at least, the bush has been over 60 centimeters tall. There's other ways I could do this as well, because each time I move to the next column, I'm subtracting 2.5. So notice here I'm going to have 87.2 take away 2.5.
Now, something I know from numbers like this, 2.5, 25, if I add it up, 2.5 plus 2.5 is 5. Let me show you 2.5 and 2.5 makes 5. So that means every 2 months the bush got 5 centimeters taller. I could use that to help me jump backwards a bit more quickly. So I could just knock 5 off of here and get to 2 months ago. But let me do the 2 steps first so that you can see I'm telling the truth. All right. 2 take away 5 I can't do, so I steal. That becomes a 6. This becomes a 12. 7. 6 take away 2 is 4. 8 take away nothing is 8. All right. Now I got to take away another 2.5 for the next month. Because remember, we're working backwards, so it's a negative sequence. 7 take away 5 is 2. 4 take away 2 is 2. And 8 take away nothing is 8. Now look, after 2 months, here's my starting point, 87.2, and now it's 82.2. The difference is in the ones place. And guess what? It's 5 apart. So what I can do to make this a little bit easier is just do every 2 months. That way I don't have to do a ton of subtraction. So to find out what 4 months ago would be, I'll just do 82.2 take away 5. If you find that a little confusing, you're like, wait, nope, I want to take it one step at a time and just subtract 2.5 each month, that's absolutely fine. You can do that. But if you want to do it a little bit more quickly, you can take away 5 for every 2 months. Remember, we're trying to find for how many months the bush has been over 60 centimeters tall. So as soon as you hit 60 or less, you're going to stop. And then you're going to check how many months you were able to go back before it was at 60 or less. I am going to give you guys a clue because I want you to work out the rest of this table on your own. Your table's going to need to be longer than this. That's all I'm going to say. It's going to go past 7 months. So when you create this in your book, you might want to make it a little bit smaller so it can hold a few more columns. All right, on to the think together portion now. It says there for question 1, the heights of the roses each month make a sequence. All the heights are in centimeters. Find the rules and complete the missing numbers. All right, what I've done in my book is I've kind of tried to recreate the table without having to draw out the entire table. I just wrote it as sequences going straight across. So I'm going to start with the white rose. In April, it was 15.1 centimeters. Then in May, 15.2. In June, 15.3. I notice here that the only thing that is changing is this place. What place have I underlined? The tenths place. The tenths place is going up by 1 each month. So I can see that each month I have to add 0.1. That means to find the other months, I just need to continue this pattern. So 15.3 turns to 15.4 in July, 15.5 in August, and 15.6 in September. I have to do October as well. So it would be 15.7. I'm not going to have space to add on October here. I didn't realize I need to put it. So you guys can go ahead and work out the Octobers. On to the climbing rose. Now remember, it said that it's a sequence, so it's going to be the same thing each month. In April, the climbing rose was 10 centimeters tall. In May, it was 12.6. So I need to work out, how did this move from 10 to 12.6? Well, I see a change in the tenths place, and I also see a change in the ones place. Fortunately, these were both zeros to begin with, so it's going to be very easy for me to see how it changed. The ones place went from 0 to 2, so I have to add 2. And the tenths place went from 0 to 6, so I need to add a 6 in the tenths place. So each month I have to add 2.6. Based on that, I need to calculate what's going to happen to the rest of the months. It's going to be the exact same addition, adding 2.6. So what am I going to get when I add 2.6 to 12.6? Take a moment, think about it, because I'm going to write it in just a second. 2 in the tenths place, carry my 1, 5 in the ones place, and 1 in the tens place. I want you to finish this pattern here. Continue adding 2.6. You can stack it off to the side, or you can try and do it mentally. If you can visualize what it would look like lined up in your head, you can absolutely do it mentally. Finally, onto the wild rose. We don't know the height for April, but we know May, June, and July. And I notice here something interesting. There's a thousands place in June and July, but there's no thousands place here. That means I can just stick a 0 in my thousands place. So now, and I see everything else is the same. 12.43 is the same in all of them. So the only thing changing was the thousands place. It went 0, 1, 2. That means each month the same thing is being added, and it's 0.01, 1,000th. So I can use that to work out my next 2 months quite easily. 12.433, because it went from 2 to 3, 12.434. How am I going to figure out the month before, though? That means I'm going to have to take away, because if I'm going to go backwards, I need to subtract. All right, well, here I had 430. Remember what I told you guys, if you ever get stumped and you're like, oh, it's a decimal, I don't know what to do, just imagine that the decimal isn't there. Imagine that this just says 430. What happens when you take 1 away from 430? 429. So I changed my thousandths place, and it ended up affecting my hundredths place as well. Remember what I told you about those patterns. You can look at them in groups if it helps. But now I can see that when I add 1,000ths to this, 0.01, it does go up to 12.430.
All right, before you start your independent work, I would like for you to do number 2 from the Think Together portion of the textbook. It says, work out the sequences and complete the missing values. So, for each of these number lines, you're going to need to find what the rule is, what is being added or subtracted for each step. Once you've found the rule, then you can find the missing numbers. Again, don't be stumped just because there's a difference in the number of digits that you see in each value on your number line. For example, 20.5 has only 3 digits and 20.75 has 4. If you need to help you work out the rule, remember to put your 0 as a placeholder in any of the empty places. For example, on that first number line, thinking of it as 20.50 will help you make the jump to 20.75 a bit more easily, and the jump from 20.75 to 21.00 more easily. And finally, the independent work, which comes from pages 30 to 32 of the workbook. I expect everyone to attempt the first 2 pages. It's exactly what we just did, continuing patterns and identifying rules involving decimals. The challenge today isn't really hard, it's just time consuming, to be honest. It's going to take you a bit of, you're probably going to need some extra paper to work this one out because it's a lot of adding. But I definitely expect that many of you are going to be able to handle that challenge today. And as always, I want you to do the reflection. When you're done, take pictures of your work and send it to me. And as always, stay safe and I'll see you soon.